Hi, my name is Ben Dunphy. I am a Master of GIS student at Penn State. My advisor is Dr. Alan Taylor. For my capstone project, I looked at prioritizing areas for Table Mountain pine restoration. Before I talk about my analyses, I want to share some background information on Table Mountain pine. Table Mountain pine is endemic to the Appalachian Mountains. It prefers poor site conditions within a specific elevation window. It is very shade intolerant and is typically found in very rocky, acidic, and excessively drained soils. While it can be found on sites outside of its natural habitat, those specimens are usually linked to human activities. It is also a fire-dependent species. This is the fruiting cone of Table Mountain pine, and they are what are called serotinous cones. This means that they only open after being exposed to heat, which usually comes from a fire. The photo on the left shows an unmature cone, while the middle photo shows a mature one. The photo on the right shows an open cone after a fire has moved through. These are a series of photos showing Table Mountain pine regeneration after a high-severity fire. High-severity fires are often called stand-replacing fires due to the fact that most of the mature trees are killed. The top left photo shows an area of the Rocky Top Fire in Shenandoah National Park a few weeks after the fire occurred. The top right photo shows an area of the same fire later in the same calendar year. The bottom left photo shows an area of the same burn area 5 years after the initial fire. Finally, the bottom right photo is from last year. The area now has a mature stand of Table Mountain pine. It was not until the modern era of full suppression that fire has largely been excluded from the landscape. Records indicate that fires were once a commonplace event that occurred every 5 to 15 years in Table Mountain pine stands throughout Appalachia. This leads to the question that I am trying to answer. Where is a suitable location to reintroduce fire to help restore Table Mountain pine? To answer that question, I chose to use Shenandoah National Park as a case study. Shenandoah National Park is located in the Blue Ridge Mountains of western Virginia. It is a little over 100 miles long and averages about 4 miles wide. It is approximately 308 square miles in size and has roughly 124 square miles of federally designated wilderness. The main reason I chose to use Shenandoah as my study area was because Table Mountain pine fills a unique ecological niche within the park's landscape. Also, during my time working at Shenandoah, I served as a wildland firefighter, and I felt that by better understanding where these trees grow and how fire interacts within these ecosystems, I could become a better steward of the land throughout my career. In order to complete this project, I conducted 3 analyses. The first analysis is the replication of a 2011 study to show where the current prescribed burn priority is located in Shenandoah, utilizing updated data. Prescribed burning is when fire managers intentionally set an area on fire to meet management and ecological goals. These goals may be, but are not limited to, reducing hazardous fuel loading, to open up the understory, and to promote the growth of fire-tolerant species. They are conducted under specific weather conditions and are extensively planned to avoid them escaping their control lines. The second is an analysis to locate suitable habitat for Table Mountain pine in Shenandoah. This analysis is based on the site conditions that are mentioned in the literature on Table Mountain pine. The third analysis is a Table Mountain pine habitat burn priority analysis. This analysis utilizes the techniques and data from the first 2 analyses to identify priority areas to reintroduce fire to help restore Table Mountain pine habitat. The data for each of these analyses was predominantly comprised of raster datasets. For the current prescribed burn priority analysis, the data needed was a fire history layer and a vegetation fire tolerance layer. For the suitable habitat analysis, a digital elevation model, an aspect layer, and a soils layer was needed. The Table Mountain Pine Habitat Burn Priority Analysis utilized the data from the previous two analyses. Additionally, a landscape compartment layer was utilized to summarize the data. In this case, it was the park's search and rescue grids. The landscape compartments in this layer are defined by ridges, streams, trails, and roads. While these are useful when searching for a missing person, these geographic features are often used to help stop the spread of wildfires and to define prescribed burn units. This layer was utilized in the initial 2011 Prescribe Burn Priority Study and is the common summary layer between all of these analyses conducted for this study. It will be used to help visually compare the results from each analysis and to help identify future project areas. The results of these analyses were several different maps. The first analysis resulted in a prescribed burn priority map summarized by landscape compartment. The second analysis resulted in a habitat suitability map, and the third analysis resulted in a Table Mountain Pine habitat burn priority map. Each of these maps can be used to better understand where Table Mountain Pine could be located and where future projects could occur to restore Table Mountain Pine to its natural habitat. The intent of the current prescribed burn priority analysis was to identify areas where prescribed burning could meet management goals and still be beneficial to the landscape as a whole if park fire managers were to conduct a prescribed burn today. The current prescribed burn priority analysis was conducted utilizing a weighted overlay. It uses the fire history data and the fire tolerance data as input. The weights were based off of the initial study conducted in 2011. Each layer was given an equal weight, and the different variables in each layer were given different priority values. The fire history layer was prioritized based on the year since an area last burned. Areas that are between 5 to 15 years since last burn are prioritized with a value of 9 because they are within the time window to have a fire pass through again. Areas that were burned more than 15 years ago were given a priority of 5 since they are past the reburn window and the ecological benefits might not be as great as if the area was still within the reburn window. Areas that were burned less than 5 years ago were prioritized as a 1 since they have recently burned and have not yet reached the reburn window time. The fire tolerance layer was prioritized so that the highest tolerance vegetation communities were given a priority of 9 and the lowest tolerance a priority of 1. The resulting output raster dataset was converted to a shapefile and the data was summarized by the landscape compartment layer using the Summarize Within tool in ArcGIS Pro. As you can see with these maps, there are relatively few high-priority compartments in relation to the amount of landscape compartments throughout the park. This is due to the fire history layer, and it predominantly reflects where fires have occurred in the past. The suitable habitat analysis was conducted using a raster overlay approach, and assumes that all of the input layers are weighted equally. The map algebra tool was used to find areas of overlap within each of the input. Initially, I selected a 1 meter DEM for this analysis because I had access to the data and the terrain in Shenandoah can vary over relatively short distances. However, after reading the documentation for the fire tolerance layer, I chose to reclassify the DEM to 17 meters to keep the resolution consistent throughout the scope of this project. Using this DEM, I created a habitat elevation layer and an aspect layer for the overlay analysis. Since Table Mountain Pine prefers specific soil conditions, I exported the excessively and somewhat excessively drained soils from the initial soils dataset and converted them to a raster dataset for this analysis. The output from this analysis represents potential habitat locations for Table Mountain Pine. The data was summarized using the landscape compartment layer so that it could be compared to the current prescribed burn priority map. One benefit of the fire tolerance layer used for the current prescribed burn priority analysis was that the modeled landscape classification data was ground truth for accuracy. When looking at the accuracy assessment plots for the landscape classification used, there are plots that confirm that some of the areas identified as potential habitat are in fact Table Mountain pine habitat. From these two analyses, it was hard to tell where prescribed burning would benefit Table Mountain pine ecologically just by looking at the mapped results. The third analysis really addresses where is a suitable location to reintroduce fire to help restore Table Mountain pine. In order to determine an approach to answer the research question, I looked at the data and the analysis techniques from both of the two previous analyses. When reviewing the report written for the 2011 study, they referenced a study conducted at Eglin Air Force Base in Florida, where a weighted overlay was used to prioritize prescribed burning locations so that fire was introduced to all areas of the base within 15 years. After reading that paper and looking into their approach, I determined that a weighted overlay was a better choice than a simple overlay analysis for this part of the project. This approach allowed me to prioritize the input based on what I found to be most important for the growth of Table Mountain pine from the literature. Since the weights for the overlay analysis can greatly affect the results, it was important to think about what would be the most important layers. Since this analysis was used to answer the research question, I determined that I needed to create a weighting scheme that prioritized Table Mountain pine habitat. I knew from my readings that Table Mountain pine prefers warm and dry site conditions, and that aspect played a major role for the location of Table Mountain pine habitat. The southwest aspect is the warmest and driest microclimate within the landscape, so these areas got the highest weight. I also knew from looking at the fire tolerance data that the only forest type prioritized as high priority in the current prescribed burn priority analysis happens to be the forest type which contains Table Mountain pine. Since this layer represents where Table Mountain pine could possibly be located in the landscape, I chose to assign it a weight towards the top. Since this analysis was also attempting to locate areas where fire should be reintroduced for habitat restoration, I chose to weight the fire history layer as the third highest value. To allow for comparison between the results of this analysis and the current prescribed burn priority analysis, I chose to keep the time since last burn priority values the same as in the 2011 study. Though it seemed to be the limiting factor in the suitable habitat analysis, based on the literature, the soil type did not seem as important as the aspect when it came to suitable habitat. This was primarily due to the fact that Table Mountain pine is known to grow outside of its natural range as a horticultural specimen and in areas of human disturbance. Unlike the two previous analyses, a landscape position layer was included in this analysis. It was derived by using a tool from the University of California, Davis called the LMU Toolbox, which classifies landscapes into 6 different slope categories. It was used in this analysis as a way to give some priority to ridgetop areas. It was not given a high weight because during the classification, the ridgetop areas do combine both southwest and northeast slope components, and from the literature it is known that the Table Mountain pine really only naturally grows on southwest slopes. Finally, elevation was given the smallest weight. This is mostly due to the fact that a majority of the park falls within the habitat elevation window, but it was included because there are a few places in the park that are not within this window. The results of this analysis show where prescribed burning may be beneficial for Table Mountain pine and the ecosystem as a whole to maintain the 5 to 15 year fire regime. Most of the potential habitat that would be suitable for prescribed burning is located in the southern end of the park. This was likely due to the location of the suitable soil and the location of past fires in the park. One of the questions that was brought up after my capstone proposal presentation and after looking at the literature again was, what effect does the weighting scheme have on the results of the data? In order to better understand this, I conducted a crude sensitivity analysis of the input data layers. To accomplish this, I varied the weights of the input data layers. When developing the new weighting schemes, I tried to keep the weights proportional to their initial weights. The only two layers I chose not to do a low weighting scheme for were the aspect layer and the fire tolerance layer, since these are the two layers that were crucial for identifying Table Mountain pine habitat. When looking at the results from the sensitivity analysis, there was little change in the overall geographical location of much of the high priority areas. However, by varying the weights of the input data, there was a change in the total area for the top 3 priority classes for these areas. After looking at the sensitivity analysis results, one thing was clear. The fire history data had a big impact on the results of the weighted overlay. This was likely caused by areas weighted in the fire history layer that are not within the 5 to 15 year reburn window, lowering the resulting weight of areas identified as potential habitat. By lowering the input weight of the fire history layer, the results better represent overall potential for Table Mountain pine habitat. Based on this, I chose to run an additional weighted overlay where I removed the fire history data completely. This resulted in a map where habitat is prioritized based on ideal site conditions and the current presence of Table Mountain pine in the landscape. The difference in the results of these two weighted overlays from a prescribed fire perspective would be the fire severity used to facilitate restoration efforts. The results from the weighted overlay with the fire history data included could indicate areas where a lower severity reoccurring fire could be utilized to open the serotinous cones and to create a receptive seed bed, since Table Mountain pine might be occurring naturally in these areas due to an active fire regime. Areas identified in the weighted overlay without the fire history data could indicate areas where a higher severity prescribed fire may be needed to reintroduce Table Mountain pine, since forest succession has taken place, which could be due to the exclusion of fire from the area due to wildfire suppression over the years. It may be hard to see, but as a parting image, I want to show you the potential habitat throughout Table Mountain pine's natural range, which has helped to reaffirm that this analytical process is not just limited to a small geographic area, but can be utilized throughout the region and anywhere there is a fire-dependent ecosystem. Thank you for taking the time to view my presentation.